Welcome to qnawire.
All right, in this question, they say that during a period of discharge, a lead acid battery, 402 grams of Pb from the anode is converted into PbSO4. So I have 402 grams of Pb, and they're telling me it's going from Pb to PbSO4. In question A, part A, says, what mass of PbO2 is reduced at the cathode during the same period? So it's a little confusing because they say it's going to PbSO4, but then they ask about PbO2. So we're going to go ahead and write it as PbO2, since that's what they ask for in the question, kind of ignoring this. And so in my equation, I would have Pb going to PbO2 instead of, PbO2 instead of the PbSO4. And so if that was the case, you can do, I'm going to set up train tracks for my stoichiometry. I have 402 grams of Pb. And I'm going to start by converting my Pb to moles. And the molar mass of Pb is 207, so 207.2 grams of Pb for every 1 mole of Pb. And since there's 1 lead for every 1 lead O2, I can say for every 1 mole of Pb, there is 1 mole of PbO2. And then the molar mass of PbO2 is for every 1 mole of PbO2, the molar mass of PbO2 is 239.2 grams of PbO2. And this gives you 464 grams of PbO2, which matches the answer key. So despite saying this to start with, I think this is what they are looking for. In part B, actually, it's a little confusing because I think that they actually are referring back to the PbSO4 and not to the PbO2. So let me set that up and show you. In part B, they are saying how many coulombs of electrical charge are transferred from Pb to PbO2. Well, if we were truly talking about Pb to PbO2, then the oxidation number here is 0. The oxidation number here is +4, which would give us 4 electron transfer, 4 electrons that are being transferred. If we set it up that way, so I'm going to go ahead and set it up that way and answer the question that they've asked, but then show you how they get the answer that's actually in the answer key. So again, I'm going to go from grams of Pb to moles of Pb. So 207.2 grams of Pb is 1 mole of Pb. And then I want to go to electrons because electrons are going to get me to coulombs using the Faraday's constant. So in this case, there were 4, for every 1 mole of Pb, there were 4 moles of electrons being transferred. And then I can say that, use Faraday's constant and say that for every 96,485 joules per volt mole, and there my moles cancel and I get joules per volt, which is actually equal to a coulomb, so that gives me my coulombs, and that is equal to 7.49 times 10 to the 5th coulombs. However, that does not match the answer key. And I think what they did is they actually went back and they really meant Pb, they did the answer key based on PbSO4 and not based on PbO2. If we look at Pb going to PbSO4, in this case, the oxidation number here is 0, and this is +2, which would mean a transfer of 2 electrons. If I change that from 4 to 2 electrons, I then get an answer of equal to 3.74 times 10 to the 5th coulombs, which is the answer in the answer key. So I believe that's what they were doing there. I think it's a typo in the problem and answer key.